Hello everyone, I am here to discuss rational functions. Before we proceed to rational functions, let's have a concept review about polynomial function. A polynomial function p of degree n is a function that can be written in the form p of x is equal to a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus up to a sub 1 x plus a sub 0, where a sub 0, a sub 1 up to a sub n are elements of real numbers, and a sub n is not equal to 0 and n is a positive integer. Each summand is a term of the polynomial function. The constants a sub 0, a sub 1, a sub 2 up to a sub n are the coefficients. The leading coefficient is a sub n. The leading term is a sub n x raised to n, and the constant term is a sub 0. We have here examples of polynomials. The first is f of x equal to 3, and the degree, which is referring to highest exponent, is equal to 0, and that is a constant function. Our second polynomial is f of x equal to negative 2x plus 1. The highest exponent or the degree is 1, and that is a linear function. For the third given, f of x is equal to 3x squared minus 5x plus 2. Our highest exponent is 2, or that is the degree, and that is a quadratic function. And for f of x equal to 4x cubed plus 2x minus 7, our highest exponent is 3, and that is a cubic function. For f of x equal to 6x raised to 5 minus 2x raised to 4 plus 3x the third power minus x squared minus 10, our degree or the highest exponent is equal to 5. We have the leading term is equal to 6x the fifth power. Our leading term is referring to the term with the highest exponent. The leading coefficient is the coefficient of the leading term, which is 6. And our constant term is equal to negative 10. By the definition, a rational function r of x is a function of the form r of x is equal to p of x over q of x, where p of x and q of x are polynomial functions and q of x is not equal to 0. The domain of r of x is a set of real numbers such that q of x is not 0. Example, r of x equal to x cubed minus 1 over x plus 1, wherein our x should not be equal to negative 1 because it makes our denominator equal to 0. Another example is f of x equal to 1 over x, wherein x should not be equal to 0. Here a real-life situation that models a rational function. The local government unit allotted a budget of 100,000 pesos for the feeding program in the daycare center. The amount will be divided equally to all the pupils in the daycare center. Write an equation showing the relationship of the allotted amount per pupil represented by f of x versus the total number of children represented by x. The table here represented the number of children and the allocated amount per child. If there are 10 children in the daycare center, each child should receive a 10,000 pesos. As you will observe, as the number of children increases, the allocated amount per child decreases. This problem can be represented by a function f of x is equal to 100,000 over x, where x represented the number of children. Now proceed to rational functions, equations, and inequalities. A rational expression is an expression that can be written as a ratio of two polynomials. Here's a table that gives the definition and example for rational equation, rational inequality, and rational function. For rational equation, that is an equation involving rational expressions. Example, 2 over x minus 3 over 2x is equal to 1/5. A rational inequality is an inequality involving rational expressions. Example, 5 over x minus 3 is less than or equal to 2 over x. While a rational function is a function of the form f of x is equal to p of x over q of x, wherein q of x is not equal to 0. Example, f of x is equal to x squared plus 2x plus 3 over x plus 1. F of x can be written also as y. From the given example, y is equal to x squared plus 2x plus 3 over x plus 1. A rational equation or inequality can be solved for all x values that satisfies the equation or inequality, while a rational function expresses a relationship between two variables such as x and y and can be represented by a table of values or a graph. We have here items 1 to 5, and we're going to determine whether the given is a rational function, rational equation, rational inequality, or none of these. For number 1, 2 plus x over x minus 1 is equal to 8. That is a rational equation. For number 2, x greater than square root of x plus 2. None of these, because of square root of x is equal to x raised to 1/2, and that is our exponent is not a whole number. For number 3, f of x equal to 6 minus x plus 3 over x squared minus 5. Okay, that is rational function. How about number 4? 2x greater than or equal to 7 over x plus 4. That is rational inequality. How about number 5? X over 2 is equal to 4 over x plus 9 x cubed. That is rational equation. Okay, try it on your own. Determine whether the given is a rational function, rational equation, rational inequality, or none of these. I'll give you a few seconds to answer the given 1 to 6. Okay, let's check for number 1. That is a rational function because y is also equal to f of x. Number 2 is rational equation. Number 3 is none of this because of the square root of x minus 2 that equals to x minus 2 raised to 1/2. Number 4 is rational equation. Number 5 is none of this because of the numerator of 4 square root of x. So square root of x means x raised to 1/2. And number 6, that is rational inequality. Okay, that's all for us. Be the highest glory. Thank you.